Cambridge Olevels Chemistry Paper 2 Theory October-November 2025 Paper 22 is what we are going to be solving today. Choose from the following compounds to answer the questions. So let's see what kind of compounds we have. The first I can see clear off is your methanol. Why is it methanol? Because look, we have one carbon that's bonded to 3 hydrogens and there's one OH group over here. So we know this is methanol. It's an alcohol. Second is a kind of like you might feel a little intimidated by the double bond O and all this thing, but it's very simple. Look, it's methanoic acid. There is a C. This double O means one O is double bonded to the carbon and the other O is single bonded to the carbon and it has an H attached to it. So this C double bond O, don't be intimidated by it. It's very simple. It's just this represented in a structural way. And then there's an H over here. So what kind of functional group is this? This is a carboxylic acid functional group. And you know that since it has one carbon and it has a carboxylic acid functional group, so what kind of acid is this? This is your methanoic acid. Okay, next we have CH3, CH2, OH. There's a OH group over here. So this is going to be an alcohol. But what kind of alcohol? It has 2 carbon atoms, and when anything has 2 carbon atoms, it's called eth. So it's ethanol. Eth means 2 carbon atoms. An means it has all single bonds. Ol means it is an OH group. Ethanol. Okay. Next you have CH3. Good. COOCH3. Now again, don't be intimidated by the CO. It's just very simple. It's just like C double bond O. This part is this. Then there's a C H H H, and the CH3 means there's a C H H and H. Don't worry. Just see the functional group. What is this functional group? C double bond O. What kind of functional group is this? This is an ester functional group. Ester. And how do you name esters? You break them like from here. You break them from here. This part is your alcohol part. So this is your methanol alcohol. And this part is your acid part. You break it from here and you realize that this acid has 2 carbons. So this is your ethanoic acid. Ethanoic acid and methanol are going to make methyl ethanoate. So this is your methyl ethanoate. Next we have a cyclic compound. There's a cycle and this is going to be butane. This is butane because there are 4 carbons and they're all single bonded. But there is one thing over here that's different. Butane is a straight chain. It's cyclobutane. Got it? It's cyclobutane. And recently I've just like seen it a lot that examiners are kind of like testing the cyclo thing a lot. So learn it. This is your cyclobutane. And remember that your cycloalkanes, this is a cycloalkane, has a similar general formula to your alkenes. Alkenes have the general formula that's CnH2n. And your cycloalkanes also have the general formula CnH2n. Like if the carbon atoms over here are 4, then the hydrogen is going to be 8. So it's going to be C4H8. And that's similar molecular formula for butene and the similar molecular formula for cyclobutane. But cyclobutane is saturated. Butene is unsaturated. Don't forget this stuff. Okay. Next we have a straight chain alkane, which is 1, 2, 3, 4. That's butane. Next we have 1, 2, 3, 4. This is butene. Then we have 1, 2, 3, 4 carbon atoms and then this carboxylic acid functional group. So this is my butanoic acid. Now I have deciphered all the stuff that I needed to. I can simply move on. State which compound is methanoic acid. I just figured it out. This one, compound B, is my methanoic acid. Is manufactured by hydration of ethene. What do you get when you hydrate ethene? This is your ethene molecule, right? Now hydration means, what is hydration? If you're hydrated, you have water, right? So hydration means addition of water. So you're adding water over here. This is an H, this is an OH, right? What's going to happen is that this double bond is going to break. One H is going to attach over here, right? And this OH is going to attach over here. So what kind of substance do you form? What is this? This is your ethanol. So when you hydrate your alcohol, when you hydrate your alkenes, you form alcohols. And what are the conditions for hydration? Do you guys remember? You need phosphoric acid as your catalyst. You need a certain temperature that's 300 degrees Celsius. You need 60 atm pressure and all that stuff. You need to remember this for the hydration of alkene. So we form ethanol. Where is ethanol? Compound C is ethanol. Has the empirical formula C2H4O. So now we have to find the empirical. I'm going to start with which compound? I'm going to start with compound H, which is butanoic acid. So first I write the molecular formula and then I cut the substances to make it into the empirical formula. So 1, 2, 3, 4. C4H. 3, 4, 5, 6, 7, 8. C4H8 and there are O2. And now I cut it. So it becomes 2 times, 4 times, 2, 1 times. Again, I'm cutting it to show you guys how is it done. Look, 2 1 times 2, 2 4 times 8, 2 2 times 4. So it's become C2H4O. Is this what they were asking for? C2H4O. Yeah, good. It's compound H. I just tried it with the last one and it just worked out. Wow, it's good. So this is H. Is used to make an addition polymer. How do you make addition polymers? For addition polymerization, always remember we need a carbon-carbon double bond. For condensation, we need functional groups like OH or like amine group or the carboxylic group, groups like this. But for addition polymerization, the only condition is we need a carbon-carbon double bond. And then what do? We break this bond and extend it. That's how we add substances. So over here, we need a substance that has a double bond. And the only substance I can see with a double bond is compound G. This double bond is shown in the structure. So compound G is an ester. We figured out an ester right over here, methyl ethanoate, which was compound D. You get it? This part comes from methanol. Initially, there was an OH here. And this part comes from ethanoic acid. Initially, there was a C double bond O, OH here. And then what happened? This part got removed. One water molecule got removed. And an ester was formed. Plus, a water molecule would have been released over here. And this is an example of a condensation reaction. Esterification is an example of condensation reaction. What kind of catalyst do we use in esterification? We use sulfuric acid H2SO4 catalyst. Okay? So D over here. State which two compounds are structural isomers of one another. What is the definition of structural isomer? What is a structural isomer? Structural isomer is anything that has the same molecular. This one's going to might be a little trickier for you, but I explained it to you. Same molecular formula and you have different structural formula. So molecular formula should be same, but structural formula should be different. Come here. Look over here. I told you something. Where is this? Look at this cyclobutane. It has a different structure compared to butene, right? But look at the molecular formula. Cyclobutane is different from your butene. They're two different things, but they have the same molecular formula, which is C4H8. Count the number of atoms, carbon atoms. 1, 2, 3, 4. Hydrogen is 1, 2, 3, 4, 5, 6, 7, 8. Over here as well, it's C4H8. But they have different structures. I told you cycloalkanes and alkenes are structural isomers of each other. So it's compound E and compound G. E and G. And just write a note over here that cycloalkanes and alkenes are structural isomers of each other. And remember this note, because I have seen examiners are testing this thing a lot. They have the same general formula, they have the same molecular formula, but different structures. Okay. A sample of titanium found on an asteroid. What are asteroids? Asteroids are basically rocky things that orbit your sun kind of stuff. Contain 4 isotopes. Table 2.1 shows the percentage abundances of these 4 isotopes. Now look. You're given with the percentage abundance. That means the sum of this all has to be equals to 100. Okay. This is your mass 46, 47, 48, 49, and this is your proton number, which remains the same for isomers. What changes for isomers is the mass number, and what remains constant for isomers is the proton number. Describe one difference between the isotope titanium 46 and 47. One difference, simple, proton number. Because one proton number is the same, the difference is simple, mass number. Because it has, titanium 47 is just one more proton than titanium 46. One difference, different proton number. Next, explain why all the isotopes of titanium have the same chemical properties. This is such a repeated question for all isotopes, for A-levels, for O-levels, both. Why two things have similar chemical properties? Chemical properties are, just write this thing or learn this thing or whatever, chemical properties are not dependent on the proton. The chemical properties of a substance is dependent on the number of electrons in the valence shell. Okay, so look, in a group, for instance, I tell you group 7. Why do you think that fluorine and chlorine have similar chemical properties? Both of them are oxidizing agent, both of them tend to gain electrons. Why? Because they have similar number of electrons in their valence shell. Both have 7 electrons. So always remember, chemical properties dependent on valence electrons. So similar, same electronic configuration. Show by calculation that the relative atomic mass of titanium for this sample is 47.84. Okay. How do you show it? You take the mass number, multiply it with abundance, like 46 multiplied by 9. Then again you take the mass number, multiply with abundance, 47 multiplied by 7. Then again you take the mass, multiplied with abundance, 48 multiplied by 75. Again you take the mass, multiplied with abundance, 49 multiplied by 9, upon the sum of abundances, which is 100. That's all you have to show the examiner. Done? And then you say that you calculated it out, even though you don't calculate, but you just do this thing right and write it, 47.84. Got it? The equation for the reaction between aluminum and dilute hydrochloric acid is shown. Aluminum, acid, AlCl3 plus H2 is what we're forming. And you know why what's happening over here. We have a metal and an acid. And you know metal and acid react to form a salt and hydrogen gas. That is what we know. Figure 3.1 shows the reaction pathway diagram for this reaction. Okay. This is the activation energy. This is the enthalpy change. How do we know it? First, you have to determine either is this an exothermic reaction or an endothermic reaction. What is this? Look, reactants are above, products are below. So this is an example of a exothermic reaction. And you know, for exothermic reactions, from your reactants to the peak, your activation energy lies. And over here, the delta H is something like this. So identify the energies, label A and B. A is your activation energy. And what is activation energy, by the way? It is the minimum amount of energy that the reacting particles must have in order to react. If you have two particles and they collide with each other, they're not going to form a product. You know why? Because the problem is they didn't collide with the activation energy. For particles to form products, like if this and this collides, it should form this, okay? Until and unless these two particles, they don't collide with each other with enough energy that's equal to or greater than activation energy, they're not going to form product. They're going to collide. They are going to collide. But the product is not going to be formed. For product to form, you need effective collisions. You need collisions that have activation energy, okay? So that's what I want to say over here. So enthalpy change. Use the reaction pathway diagram to explain why the reaction is exothermic. How did I just figure it out? I told you, reactants had more energy than the products. This is your energy level. Over here, you can see a higher energy level. Over here, you can see a lower energy level. So you write, reactants have more energy than the products. Describe a chemical test for hydrogen. You have to learn all the chemical tests for gases like hydrogen, carbon dioxide, ammonia, sulfur dioxide. You have to learn it. For hydrogen, I've learned it. It's a lighted splint, and then it extinguishes with a pop sound. I write lighted splint, and then for observation, extinguishes with a pop sound. Pop is very important. You take a splint. Splint means a wooden rod that has some kind of fire on it, something like this. And then when hydrogen gas, I'm showing hydrogen gas with pink color, don't judge me. If hydrogen gas is going to come into contact with it, this is going to extinguish. That means it's going to blow out. And there's going to be a pop sound like this. Got it? That's going to be the sound. I'm giving you ASMR as well, so you know what's a pop sound. It's like, got it? A sample of aluminum reacts completely with dilute hydrochloric acid. So we have aluminum, and then it reacts completely with HCl. Okay, that means aluminum is the limiting reactant because it's reacting completely, and HCl is the excess reactant. Okay, a total volume of this amount of hydrogen measured at RTP is produced. Calculate the mass of aluminum. Give your answer to two significant figures. No worries. What are we given with? We're given with the volume of our hydrogen. Can we calculate the moles of hydrogen? Yes, whenever we have volume, whenever we have anything like volume, mass, concentration, we always calculate out the moles, because moles is the way to go. So moles equals to for volume, moles equals to your volume upon 24, but it's in cm cube, so you just put 1,000 over here to get your correct moles. So moles equals to, what's my volume? It is 366 upon 24,000. 366 divided by 24,000, and that gives me whatever this thing is. Okay, so I have my moles. Now once I have my moles, what do I have to do? I need to calculate out my mass of aluminum. So my concern is to find the moles of aluminum. How do I calculate the moles of aluminum? I go to my equation. I say that 2 moles of aluminum react to form 3 moles of hydrogen. 2 moles of aluminum are forming 3 moles of hydrogen. So I'm going to create a molar ratio over here. And my ratio is going to be aluminum ratio hydrogen. My 2 moles of aluminum are reacting to form 3 moles of hydrogen. Now, if these many moles of hydrogen are formed, which is 0.01525, how many moles of my aluminum are going to be reacting? Got it? What are we doing? We're forming ratios. This forms this. So if this is formed, what's going to be this? Got it? So it's going to be, X is the moles of aluminum, which is going to be 2 into 0.01525 divided by 3 multiplied by 2 divided by 3. That gives me, this is my moles of aluminum, which I found out. Okay, my moles of aluminum are here. Now, what do I have to calculate? The mass of aluminum. If I have the moles of aluminum, how do I calculate the mass? Remember, moles equals to mass over mr. Moles are 0.01016667 multiplied by the mr of aluminum. So what do? I go to my product table. I say, this is my aluminum. What's the mr? By the way, I know many people, what do? They take 13. Please don't do this. This is going to ruin your, I don't know what it is going to ruin, but you take 27 as your AR or the mr. That's the thing you have to take. So it's 27. Multiplied by 27 equals to your mass. So times 27. This is my mass of aluminum. Got it? I hope that you guys do. If you don't, then tell in the comments below. I'm going to try my best to make it easier. Okay. Fluorine, chlorine, bromine, iodine are elements. We have fluorine, chlorine, bromine, iodine are elements of group 7. Fluorine has a low boiling point. It is a gas at room temperature. Describe the arrangement and motion of molecules in fluorine gas. So it's not about fluorine. It's about a gas. Like any gas, it's about the motion and arrangement of particles in any gas, not just in fluorine. So it's gonna be, okay, so it's gonna be, what is the motion? Particles are free to move, they're far apart, they have random motion, they're randomly arranged. So when arrangement and motion, random arrangement, particles are random, their random arrangement is random, their motion is random, they're far apart. I guess that's elementary school science. Solid, liquid, gaseous, particle arrangement, that's the easiest thing. Far apart and weak intermolecular forces. Weak intermolecular forces. You write all this stuff. What do you know about gases? Okay. Explain why fluorine is a gas at room temperature. Use ideas of structure and bonding. Fluorine. What's the molecular formula of fluorine? Now, you guys are going to say it's F. Incorrect. Not F. What's the molecular formula? It's F2. 2 atoms of fluorine covalently bonded. Guys, see this. This is fluorine. This is fluorine. This is fluorine. A single atom of fluorine cannot exist. I know you guys forget it. You think one atom of fluorine, oh my god, how do we figure out the structure? What is the structure? What kind of thing is going on? Bro, it's a bonded atom, like it's a diatomic molecule. Okay, use either structure and bonding. Structure is simple molecular. This is a molecule of fluorine. So it's a simple molecular structure बता दिया. Now bonding with weak, you have to tell why it's a gas. That means it has weak intermolecular forces. Because why is something a gas? Because the particles are not tightly held together. That means there are weak forces. This is one fluorine molecule. Okay, this is your, let me tell you, you're gonna understand it, don't worry kiddos. This is your one fluorine molecule. This is another fluorine molecule. Between these two fluorine molecules, there is this space. there is this space, and between this molecule and this molecule there is this weak intermolecular force, weak intermolecular between two molecules, that's holding them together, and that's very weak. So if this was strong, then it would have been a liquid or a solid, but it's weak, so it cannot hold the two together. Okay, with weak intermolecular force of attraction, bromine reacts with lithium to make an ionic compound lithium bromide. Suggest two physical properties of lithium bromide. So basically they're asking about the physical properties of an ionic compound. Over here I'd like to tell you guys about a very important word, which is physical properties. Physical properties means there's a difference between the physical properties and the chemical properties of a substance. Physical means something you can see, like electrical conduction, like high melting and boiling point, like high density. These are physical properties. And chemical properties are oxidation states, and those that include the electrons and structures. So physical properties of lithium bromide. Lithium is group 1, bromide is group 7. There's ionic bonding between this. This is LIBr. And the physical property is simple. Ionic compounds, oppositely charged ions that are attracted to each other because of what kind of force? What kind of force? Only attractive force. The name of the force is electrostatic force of attraction. So there is high melting point. I'm just writing MP, but you write the full form. And BP, boiling point. And then the second thing that I can think of is good electrical conductivity in aqueous or molten form. Good electrical conductivity in aqueous or molten form. And don't forget one thing, that you have to tell the examiner. You just don't write good electrical conductivity, because you know in solids lithium bromide cannot conduct. Why cannot it conduct? Because ions are in fixed positions. Ions cannot move. An ionic compound can only conduct electricity when the ions are free, when the ions are mobile, when they can move, right? Construct the ionic half equation to show the formation of lithium ions from lithium atoms. So we have to show the formation of lithium ions. This is a lithium atom. It's in group 1. Group 1 means it loses one electron to form Li plus 1 plus 1 electron. Got it? Important stuff. Okay. Construct the ionic half equation to show the formation of bromide ions from bromine molecules. Over here we have molecules. Over here for lithium we had atoms, because lithium exists in the form of atoms, but bromine exists in the form of molecules. I told you it's a diatomic like fluorine. There are two atoms covalently bonded. So there's going to be a bromine molecule and there are two atoms in it. So 2 electrons are going to be gained. 1 electron is going to be gained by one atom, another electron is going to be gained by an other atom to form 2Br negative. Chlorine gas is bubbled into aqueous lithium bromide. So you have chlorine gas, Cl2, and then you're bubbling it into lithium bromide. Look what's going to happen. You have chlorine and you have LiBr. Chlorine is a more stronger oxidizing agent. It can take away electrons from your bromide. So what's going to happen? Bromine over here is a negative one. You're going to form LiCl plus Br2. What's going to happen? Chlorine is 0 over here and there's a negative 1 on bromine. Chlorine is going to take away this 1 electron and it's going to form Cl negative 1 and bromine is going to go to 0. So what's happening over here? This is a redox reaction, and if you balance it out, there's going to be a 2 here and a 2 here. So the two products of the reaction are bromine, because chlorine has taken away the electrons from it. Now it's just a liquid, and lithium chloride. So you have your lithium chloride plus bromine. And what kind of reaction is this? This is called a displacement reaction. Why is this called a displacement reaction? Because one halogen is displacing another halogen from its halide compound, or from its salt. This is a salt of a halogen, and this is an other halogen that is displacing it. Got it? nickel is a transition element, we know it. One of the properties of nickel is that it's a catalyst. Catalyst, you know, what does a catalyst do? It speeds up the reaction. State the reaction that uses nickel as a catalyst. Do you guys remember when you had an alkene like this? Remember? And you added your hydrogen to it, hydrogenation of an alkene. You add it to it, and then you add nickel catalyst. You have 200 degrees Celsius temperature. What happens? This double bond breaks from here. One hydrogen attaches here, one hydrogen here. So it's addition of hydrogen to ethene. It can be propene, butene, pentene, hexene, heptene, octene, nonene, whatever. Whatever kind of alkene you have. If you add nickel and hydrogen to it, the double bond in the alkene is going to break to ethene. State the other chemical property of the nickel that is typical of a transition element. High density, typical of a transition metal, more than one oxidation state, forming colored compounds. But you have to think over here. I told you a trick. I told you 3-4 properties. Out of them, you can only write one. Forming a colored compound is a physical property because you can see it. The things you see are physical properties, right? High density is a physical property because you can see it. You put it in water, you see it sinks because it has high density. But can you see the oxidation state on nickel? Can you see the oxidation state on copper? No, you cannot, because it's a chemical property. Chemical property means it has to deal with the electrons, with the protons, that stuff. That's chemical properties. You cannot see the electrons. You cannot see the oxidation state on nickel or copper or whatever. So that's a chemical property. State the other chemical property of nickel that is typical of a transition element. So, different oxidation state or variable oxidation state. You know, transition elements have variable oxidation state. Copper is +1 and copper is 2+ as well. 2 oxidation state. Iron is 2+ and iron is 3+ as well. So this is what transition elements are going to do. The physical properties of nickel. Now again, switching to physical properties. I know majority candidates would have messed up over here with a chemical property. They would have probably written a physical one because I know the dynamics of the question are such that you don't understand it, but let's continue. The physical properties of nickel and its alloys can be explained by using ideas about structure and bonding. Explain why nickel is malleable. What does malleable mean? Malleable means it can be turned into sheets. Why? Because look, what is nickel? Nickel is a metal. What do metals have? Metals have positive ions. Remember, what is metallic bond? Metallic bond is that you have your positive ions in a sea of delocalized electrons. This is your sea of delocalized electrons. Good. Now, it is malleable because when you're going to push it, when you're going to apply force from here, what's going to happen? This entire layer is going to slip and slide like this, right? That's why it's malleable. That's why you can turn it into sheets. You know, pure metals are soft actually. You can turn them into shapes because they have layers that can slide without the metallic bonding being disrupted. So if I apply force, this is going to slide like this. That's why you can make jewelry out of your gold and silver and whatnot. Okay. So over here, explain why nickel is malleable. It has layers of positive ions that can slide over one another. It has layers of positive ions that can slide over one another when force is applied without the metallic bond being disrupted. Nickel and other elements are added to iron. Okay, so now they're added to iron. What are you doing? You're making alloy. You're mixing up metals. When you mix up metals, you make them harder and stronger. Why does it become harder and stronger? Because look, this is nickel, right? Now, if you add iron to it, iron atoms are gonna be, let me show it to you guys. Look, this is your nickel. Explain why stainless steel is harder than pure nickel and pure iron. I'm gonna explain it. This is your nickel, right? Nickel has, I'm talking about nickel right now. It is one size of atoms. All atoms have one size. But if I add another metal to it, now what's going to happen? In some places, I'm going to draw some atoms that are of different sizes. Now tell me, when you apply force, this is a bigger atom. Now, will the layers slide over each other easily? They won't, because of different size of atoms. Now, this is not malleable enough. That is why when we think of metal, we think of our iron gates. We think, oh my god, we think of cars. We think, why aren't cars that malleable if this, like, metals are malleable? Because that's not just one metal, that's an alloy. Your cars, your gates, your door handles, your knobs, they're all made up of alloys, metals mixed with other metals to make them harder, to make them stronger, so that their layers don't slide. Got it? So over here, I'm gonna tell, because of layers of different size of atoms, they don't slide over each other. Okay. What the question says, explain why stainless steel is harder than either pure nickel or pure iron. Stainless steel has layers of different sized atoms which don't slide over each other. So when force is applied, the layers do not slide over each other, making it harder and stronger than pure metals. Pure metals only had these red atoms that would slide, but your alloy had this red and this purple metal, so it's not gonna slide. Got it? Stainless steel is used to make cutlery because it is hard and strong. Okay, stainless steel is used to make cutlery because it's hard and strong. State one other property that makes stainless steel suitable, resistant to corrosion. You don't want your cutlery to rust because it's made up of iron, right? It has nickel and iron. And what's good about iron? It rusts, right? It's always gonna rust. Iron rusts. We all know it forms Fe2O3 with oxygen. It forms iron oxide, right? And there's gonna be like water XH2O as well. So prevents it from rusting. And why does it? That's why we make alloys. We don't want it to rust. We want it to be harder. We want it to be stronger. We basically want it to have a different melting point, because impurity increases the melting point. So if you are making mixtures, you are making them impure, like adding different metals, you are basically disturbing their melting points as well, because impurity increases the melting point and decreases the boiling point. Increases the boiling point, decreases the melting point. Yeah, water boils at, check it out. Impurity increases melting point. What is this? Impurities do not increase the melting point, rather they lower the melting point. I told you, impurities lower the melting point and they increase the boiling point. Water that has salt in it is not going to boil at 100. It's going to boil at 105, 110, whatever, above 100. And water that has salt, the ice of that water, because it's impure, is going to melt below 0. Got it? Chalo. Compound X contains nickel, hydrogen, and oxygen only. X contains this much hydrogen, this much oxygen. Calculate the empirical formula. No worries. So it has nickel, it has hydrogen, it has oxygen. 2.2 hydrogen, 34.5 oxygen. Then how much nickel? 100 is the total. Sum of this percentage and this percentage is going to be 100. So 100 minus 2.2 minus 34.5. 100 minus 2.2 minus 34.5. 63.3% is going to be nickel. 63.3%. Now what do? You find the moles. How do you find the moles? You divide them by their AR. Oxygen is 16, hydrogen is 1, and nickel is, let's go down and find nickel. Nickel is 59. Don't mess it up by writing 28. I know people do this. 59. Now when we divide them all, we get their moles. The moles for nickel is coming out to be 1.07, for hydrogen 2.2, for oxygen 2.16. Now what do? You divide all of them by their smallest mole. This is the smallest mole. So I divide all of them by 1.07, 1.07, 1.07. What do I get? I get 1:2:2. That means I have 1 nickel, 2 hydrogens and 2 oxygens in my empirical formula. So it is Ni, 1 nickel, 2 hydrogens and 2 oxygens. Got it? What do? You take the percentages, divide them by their MRAR, and then you divide the answer with the smallest percentage. Okay. The equation for the reversible reaction between carbon monoxide and nickel is shown. No worries. The forward reaction is exothermic. This is exothermic. Then that means the backward reaction is endothermic. Forward exo, backward endo. Got it. The reversible reaction is allowed to reach equilibrium in a closed system. Okay. Predict and explain the effect of increasing the pressure on the position of the equilibrium. The temperature remains constant. Now we're dealing with the temperature. We don't need exo-endo. For temperature, we only need the gaseous moles. Over here, we have how many moles of gases? Now people are going to say 5. No, bro, this is a solid. So there are 4 moles here and 1 mole here. And what are we doing? We're increasing the pressure. When you increase the pressure, the equilibrium moves towards the side that has less moles or more moles? Less moles. So it's going to move forward because forward has 1 moles. So we write prediction, equilibrium shifts forward. And why? What's the reason for equilibrium shifting forward? Because there are less moles of gases on the product side. Or you write 1 mole and 4 mole. Less moles of gases forward key in brackets we can write right. Less moles of gases on the right side. Or you can write the reverse argument, more moles of gases on the reactant side. Good. This question is about covalent compound hydrogen peroxide. It's a covalent compound. When we hear covalent compound, what do you get? We get low melting boiling point. We get poor negligible electrical conductivity. That's all what comes to our mind. Figure 6.1 shows the displayed formula of hydrogen peroxide. OOHH. Okay. No worries. Draw the dot and cross diagram to show the electronic arrangement of the molecule of hydrogen peroxide. Draw the outer shell electrons only of oxygen and hydrogen. No worries. 1 oxygen. No, we have to draw property. 1 oxygen. Another oxygen. Then we have 2 hydrogens. 1 hydrogen. Another hydrogen. And then we have to show the outer electrons, like all of them. So 1 bond here. Oxygen, oxygen. I need to make sure that I use crosses for oxygen. So I am going to make crosses for oxygen. 2 crosses here, oxygen, oxygen, and dots for hydrogen. So 1 dot for hydrogen here, 1 dot for hydrogen here, 1 cross here, 1 cross here. And then what do? I complete the octet for oxygen. And do I need to make 8 electrons for hydrogen? I know majority is going to do this stuff. They're going to add electrons here for hydrogen. Like, oh my god, it is an octet. So 1, 2, 3, 4, 5, 6, 7, 8. No. A complete no. Hydrogen follows the duplet rule because it has one shell only. And the capacity for the first shell is 2 electrons. Got it? To gain these 2 marks, you have to show the examiner that you know oxygen has 8, hydrogen is 1, and the rest. Okay, a sample of hydrogen peroxide has a mass of this. Calculate the number of moles of hydrogen peroxide in the sample 1 mole of hydrogen peroxide contains. Okay, so I have to calculate the number of molecules. No worries. I have the mass. First, I'm going to calculate the moles. Simple. Moles equals to my mass over my MR. Moles equal to my mass, which is 0.170. My MR of hydrogen peroxide. 2 hydrogens. 1 hydrogen is 1. So 1 plus 1, 2 oxygens. 1 oxygen is 16. So 16 plus 16. So 16 plus 16 plus 1 plus 1. 16 plus 16 plus 1 plus 1. 34. But you know what? I want to show the examiner my workings, so no, but still 34. My moles come out to be 0.170 divided by 34. 0.170 divided by 34. 0.005. 0.005 moles. We got the moles. Now, what do we have to do? We have to figure out the number of molecules. How do we figure out the number of molecules? Think about it. 1 mole contains 6.02 into 10 exponent 23 molecules. So 0.005 moles are going to contain X number of molecules. X equals to 6.02 into 10 exponent 23 divided by 0.005. Okay. So we used ratio method. If 1 mole contains this much, these many moles will contain this much. So over here, we're going to have 3.01 into 10 exponent 21 number of molecules. Got it? Now calculate the total number of atoms in a sample of hydrogen peroxide. Remember, we have these many molecules. So you make the ratio again. 1 molecule, this is 1 molecule, this is 1 molecule. Okay, so 1 molecule contains how many atoms? 1 atom, 2 atom, 3 atom, 4 atoms. 1 molecule contains 4 atoms. So 1 molecule contains 4 atoms. So 3.01 into 10 exponent 21 molecules will contain X number of atoms. X equals to, we're finding the atoms, 3.01 into 10 exponent 21 multiplied by 4 equals to 1.204 into 10 exponent 22 atoms. I'm going to explain it again. 1 molecule contains 4 atoms. So if we have these many molecules, which are 3.01 into 10 exponent 21, we're going to have X atoms. X equals to this multiplied with this. I hope this is clear. When aqueous hydrogen peroxide reacts with acidified KMnO4, we know this is a redox reaction. We have H2O2, we have KMnO4. KMnO4 is used to test for reducing agent or oxidizing agent. Reducing agent. KMnO4 is used to test for your reducing agent. If you add this fella to a reducing agent, it's going to change color from purple to colorless. There's a color change from purple to colorless. When aqueous hydrogen peroxide reacts with aqueous potassium iodide, there's a color change from colorless to brown. See this, colorless to brown. There's a color change. We have potassium iodide. Potassium iodide is used to test for oxidizing agent. So here, what can we see? When we add KMnO4, that is used to test for reducing agent, it changes from purple to colorless. That means hydrogen peroxide is a reducing agent. Okay, this is a reducing agent because it's changing from purple to colorless. And potassium iodide, that is used to test for oxidizing agent, changes color from brown, colorless to brown. This means hydrogen peroxide is also a oxidizing agent. So if it is both reducing agent and oxidizing agent, then what can we tell about the chemical properties of hydrogen peroxide? Simple. When we add it to KMnO4, it changes from purple to colorless. That means it's an oxidizing agent. When we add it to Ki, it changes from colorless to brown. That means it's a reducing agent. So it is both an oxidizing agent and a reducing agent. Okay. Barium peroxide reacts with cold dilute sulfuric acid to produce H2O2. Barium peroxide contains ions barium 2 plus O2 negative. Reduce the formula of barium peroxide. Ba2 plus O2 negative. 2 plus and 2 negative cancel out. What do we form? We form BaO2. Now what are gonna people do? They're not gonna realize one thing. This is O2. This is a peroxide ion. In peroxide ion, you have O2 which has a charge of 2 negative. I know. You guys know O has a charge of 2 negative. You're correct. That is normal oxide ion. But this is not an oxide ion. This is a peroxide ion in which your single oxygen has a charge of -1 because 2 oxygens have of 2 negative. I know that's unusual for oxygen, but that happens in this sign. So over here, 2 plus and 2 negative cancel to form BaO2. So the formula for this is going to be BaO2. Don't be intimidated by it. I'm going to get it. The equation for the decomposition of hydrogen peroxide is shown. The rate of decomposition increases as the temperature of the aqueous solution increases. Explain why. Okay. Why does rate increase when temperature increase? Because the kinetics of the reaction increase, the temperature increase. Got it? Explain why. The explanation for this is going to be the particle are going to gain kinetic energy. Particles gain, your explanation should be clear, gains kinetic energy. And the rate of the reaction, this is what the examiner stated, so I'm not going to write it. And the frequency of effective collisions increases. And then I'm going to tell, whenever you increase temperature, what happens? More particles have energy greater than or equal to activation energy. More particles have energy equal to or greater than activation energy. More particles have energy greater than or equal to activation energy. Okay? Increasing temperature does this. It does not only increase the frequency of the collision, it also makes more particles have energy greater than activation energy. And when particles have energy greater than activation energy, that's only when they can react. If two particles collide, they don't have activation energy, no product is going to be formed. Describe how a catalyst increases the rate of decomposition, it lowers the activation energy. So now, what's going to happen is that even if particles collide with less energy, since the activation energy has been lessened, it simply does this. Like if you get out of 50, for instance, in my test, I make a test and out of 50, the passing marks are 30. Okay, I say only the students who get 30 or above are gonna pass. So now, out of 100 students, only 3 students pass the test. Okay, because my test is extremely hard. Okay, now you know what is catalyst gonna do? It's gonna make the passing marks less. It's gonna say that out of 50, now the passing marks are 10. If I decrease the passing marks, now what's gonna happen? Now the marks of the student didn't change. The passing marks changed. So now how many students will pass the test? Now maybe 16 or 17 students pass the test. Got it? because 16 or 17 now have greater than 10. But initially, when passing marks were 30, only 3 students passed. So catalyst is lowering the passing marks. Passing marks are the activation energy. Only if you have more, you can pass the test. Otherwise, you will fail. So over here, you say lowers the activation energy. PET is a polyester. It is a condensation polymer. Figure 7.1 shows the two monomers used to make PET. What is a condensation polymer? You're going to remove water from it. OH from here, H from here, going to form water. There's going to be an ester bond formed over here. That's going to be condensation. Name the two types of monomers used. Dicarboxylic, two carboxylic acid groups, and diol, two. When you have a single ol, you call it ol, like ethanol, propanol. But when you have two alcohol functional groups, you call it a diol. So this is a dicarboxylic acid, and this is a diol, not single ol. Di means two alcohol functional groups, two acid functional groups. Don't forget this. The two monomers react to make PET and a small molecule. What is that small molecule? I told you, water is going to be released. So, name the small molecule. Water. Very good question. Draw the structure of PET. Your structure should include 2 repeat units. Nothing, no worries. First things first. Now, what do? We know we have to remove some stuff. We have to remove OH from here. We have to remove this. We have to remove OH from here. We have to remove this. We have to remove H from here. And we have to remove H from here. Okay, done? Yahi karna na? That's what I told you. You have to remove OH from here, H from here. Now I've removed all this stuff. Now I draw it without this stuff. This box is black, so I have to make it black. Okay? Don't do this mistake of leaving it uncolored, because black means different. This white means different. Then I have C double bond O. I don't have to make the OH. I join it to this O. I have to make the O. Then I make a white box. And then I just make a O over here. This is my 1 repeat unit. But how many repeat units do I have to make? 2 repeat units. I copy my 1 repeat unit. What do? I bring it down here. And I have to make 2 repeat units. One repeat unit. Another repeat unit. Done. Extension bond here. Close it from here if you want. If you don't want, don't. And you are done. That's all. Done. State 2 environmental challenges caused by the disposal of plastics. Plastics are harmful. They cause a lot of problems. Firstly, they accumulate in the oceans, and then they're gonna cause problems for the fish over there. Their reproduction cycle is disturbed, their breathing is disturbed. The fish are like extremely affected by this. So accumulation, and plastics are non-biodegradable. They don't decompose. The fungi and the bacteria cannot break them. Accumulation in oceans. Number 2, they fill the landfill sites, because if you put a banana peel or an orange peel in a landfill site, it's going to decompose and disappear. But if you put a plastic in a landfill site, it's not going to disappear for millions of years. So it's going to remain there. It's going to cause visual pollution. And humans are also going to decompose. We all are going to decompose one day. So fills landfill sites. And that's a problem. And this accumulation in oceans is very dangerous for the turtles, because turtles are like kind of naive. They think that plastic is food, and then they eat it, and then they have problems. Okay, name one polymer that's a polyamide. Condensation polymer that's a polyamide. proteins and nylons. Proteins are made up of amino acid monomers, and nylon is made up of diamine and dicarboxylic. So either you can write proteins, they're also polyamides because they're made up of like amino acid monomers, or you can write nylon. Nylon is synthetic, man-made. Proteins are natural. Figure 8.1 shows the displayed formula of unsaturated carboxylic acid. X explained why X is unsaturated. Unsaturation means there is a carbon-carbon double bond. Got it? So explain why X is unsaturated. There's a carbon. This is unsaturation. There is a carbon-carbon double bond. If someone thinks that this is also a double bond, so it also must be unsaturation, no. The double bond must be between two carbon atoms. If there's a double bond between carbon and oxygen, you don't care. That's not unsaturation. Unsaturation is only going to happen between two carbon atoms. So remember this. This is not unsaturation. Unsaturation means double bond here. Describe the observations when X reacts with bromine. Whenever you have an unsaturated compound, it reacts with bromine, the double bond breaks, one bromine adds here, one bromine adds here, and the bromine changes color. It turns from brown to colorless. So bromine changes, I tell you why. Color from brown to colorless. Why? When the bromine is like this, it's brown in color. But when this bond breaks, one bromine adds here, one bromine adds here, this bond of the bromine breaks. So now it becomes colorless. Unless this bond exists, until and unless this bond exists, it's going to remain brown. But when this bonds break, one bromine got here, one bromine got here, you are done with the brown color. It's gone. X is a weak acid. Describe the meaning of the term weak acid. Partial ionization. It does not ionize fully. That is what a weak acid is. So partial dissociation, not full dissociation. Partially dissociates in aqueous. I tell you what this means. If you have ethanoic acid, which is CH3COOH. Now, you know this H has to dissociate and form CH3COO negative plus H plus. Now, what's going to happen if it's a weak acid, all the carboxylic acid molecules are not going to form this H plus. Some are going to remain like this. So what happens is it becomes a reversible reaction. It goes forward, it goes backward as well. So it doesn't fully dissociate. Not all H are going to form H plus. But if you have a strong acid like HCl, it's going to form H plus and Cl minus. And this is not going to form HCl again. This is a single forward reaction, but this one is a reverse reaction. Okay, name the gas formed. X reacts with aqueous sodium carbonate. What is X? It's an acid. We don't care if it's weak or strong, but it's an acid and it's reacting with a carbonate. And when we know that acids react with carbonates, what kind of gas do we produce? We form carbon dioxide gas. When acids react with metals, we form hydrogen gas. We don't forget this stuff. Describe how an ester is prepared from X. Okay, so for X is a weak acid. In acid, how do we prepare esters? Acid plus alcohol gives you an ester. We heat it, and then what else do? We add sulfuric acid catalyst. Please don't forget this. We have to heat it and add sulfuric acid catalyst. So you just write it. Reaction of an acid with alcohol, heat it and add H2SO4 catalyst. Done. Ethanoic acid is saturated. Saturated means all carbon-carbon. This is ethanoic acid. This is saturation. Carbon-carbon single bond is saturation. You might think there's a double bond here, but this is carbon-oxygen double bond, not carbon-carbon double bond. It describes how ethanoic acid is made from ethanol. Do you guys remember? You have alcohol, you oxidize it, you have an alcohol. This is your alcohol. Okay? This is your ethanol. And now what do? You add oxygen to it. And when you add oxygen to it, what happens? This H removes from here. This H removes from here. And this oxygen goes over here. You form a double bond here. That is what is happening. So, describe how ethanoic is from ethanol. Add aqueous acidified KMNO4 to alcohol. Or simply say, add a oxidizing agent. Okay? Dilute ethanoic acid reacts with sodium. Ethanoic acid reacts with sodium hydroxide. You have an acid and you have an hydroxide. Name the two products. Acid plus alkali. What are the products? Acid plus alkali gives you salt and water. Water is what we know. But what's going to be the name of the salt we're going to form? That depends on the type of acid and the type of alkali we're using. We're using ethanoic acid and we're using NaOH as alkali. So we're going to form sodium ethanoate as our salt. Sodium ethanoate and water. Zinc chloride, hydrated zinc chloride is a white solid. State the meaning of the term hydrated. So zinc chloride is ZnCl2 and hydrated means it has some water attached to it. It's chemically combined to it. Meaning of the term hydrated means water chemically combined. Dissolving something in water is a different thing, and having water chemically combined with something is a different thing. Okay, so there's a chemical combination of water. So we tell the examiner this is a chemically combined water. Aqueous ammonia is added. Okay, we have zinc ions, remember. Test for cations. We're adding aqueous ammonia. Dropwise until in excess to a small volume of aqueous zinc chloride. Describe the observations. What happens when we add ammonia to zinc ions? You have to learn the test for cations. White precipitate forms that is soluble in excess ammonia. White precipitate forms that is soluble in excess ammonia. Describe the observations when aqueous silver nitrate is added to aqueous zinc chloride. We have a chloride ion. He's testing your test for cations and anions. Simple for ammonia, he tested your test for a cation, and over here he's testing your test for chloride ions. So we form a white precipitate of what? Of silver chloride. Look at this reaction. It is silver nitrate reacting with zinc chloride, and then you form AgCl plus ZnNO3 2. So this is the precipitate that's forming. Soluble, soluble, insoluble, the precipitate that's going to form, insoluble. So that is basically a precipitation reaction. Got it? You're making a salt out of your precipitation reaction, an insoluble salt, and that is what gives you precipitate. Complete. Dilute and concentrated zinc chloride are electrolyzed separately using carbon electrodes. Complete table 9.1. So first we're gonna do the dilute one. Dilute one, we know when we have dilute, we don't form the chloride. Whenever we have dilute, we don't form the chloride. On the anode, we're going to form oxygen gas. Okay, oxygen gas from the water. And when At the cathode, we're going to form hydrogen gas. Obviously, we cannot form zinc. Why? Because zinc is above in the reactivity series compared to hydrogen. Hydrogen is below zinc. The below you are in the reactivity series, the more chances you have of forming. When we have concentrated, then we form the halide. So over here, we're going to form chlorine gas. And over here, again, zinc cannot form because it's above hydrogen. So over here, we're again going to form hydrogen gas. Okay. Explain why aqueous zinc chloride conducts electricity but solid zinc does not conduct electricity, because zinc chloride is an ionic compound. Aqueous means it has positive and negative ions that are free to move. Solid means ions cannot move. Aqueous solution has free mobile ions, whereas in solid ZnCl2 ions are held in fixed positions, unable to move. Got it? Water is important as part of the environment. River and lakes are natural source of water. Name one substance in water that may be harmful. Explain why this substance may be harmful. Plastic, metals. Substance is plastic, and my explanation is going to be accumulates in water and does not decompose. So it is dangerous for marine life. Name one substance in river water that is beneficial. Explain why this substance is beneficial. Oxygen. Got it? Oxygen is the only thing that's dissolved in water that's beneficial. Oxygen provides energy source, like for the oxidation of the glucose that you eat, for marine life. Describe the 3 processes involved in the treatment of water for domestic supply. You have to learn this stuff. Like, you have to learn the 3 steps that are very important. Process 1 is sedimentation. What do you do in sedimentation? I tell you. It's simply like filtration. You remove the insoluble things. So this is your water. It has solid impurities, like big solid impurities. What you do is you simply pour the water, filter it, and pour it in a way that all the insoluble things are gonna like filter out. They're gonna be moved away. Sedimentation. Number 2 is chlorination. Chlorination means killing microbes. The microbes you cannot see, like the harmful bacteria. And number 3 is adding carbon. So, carbon adding carbon, like my English sucks, but it's fine. Adding carbon. Sedimentation, what does it do? Removes insoluble substances. Chlorination kills microbes. Microbes means harmful bacteria and other bacteria as well. Harmful microbes, because microbes are all the bacteria. We say kills harmful microbes. Adding carbon, it just moves those bad taste and odor in water. It removes bad taste and any smell or odor in water. Done? Describe a chemical test to show the presence of water. You know you can use 2 things to test for water. Number 1 is your copper sulfate anhydrous. Your anhydrous CuSO4, that is going to turn from, if you add water to copper sulfate, that is anhydrous, it's going to become hydrated and it's going to turn from white to blue. And the second thing you use is your anhydrous cobalt chloride, COCl2. And then what happens? It turns from, if there's going to be water, you add the substance to it, and if the substance contains water, this gonna turn from blue to pink. Okay, explain how the purity of water is tested using its boiling point. Pure water has a fixed boiling point. Pure water has fixed boiling point of 100 degrees Celsius. Anything that pure, it's going to have fixed melting and boiling point. Impure substances have variable melting boiling point. They have a range of melting boiling points, but fixed substances have single melting point. Pure water, the ice made from pure water melts exactly at 0, boils exactly at 100. So we are done.